Hello guys, welcome to this video. So in this video I am going to give you a demonstration of my DSA module uh, problems. So there are 25 problems total in this module of DSA, and I am going to explain 5 of them according to the Almabetter. So before that, myself Ankish Sharma, and I am the alumni of Almabetter of a group called Calls. And right now I'm going to demonstrate you 5 questions which are 1, 7, 11, and 16 and 21. So let's start this video. So you can see in the first question, this code check if a number n is a power of 2, it gives. So by first verifying if n is greater than 0, to ensure it is positive, it should be positive, and which means both the conditions needs to be true. uh, Operation between and n minus 1 will have all its bits flipped after the rightmost one. If n is power of 2, the bitwise AND will result in the 0. Therefore the condition and n minus 1 triple equals to 0. Check this property returning true if n is indeed a power of 2 and false otherwise. That's it. So now let's start with question number 7. So you can see there's a question to check the condition palindrome. So you know what is palindrome stands for. Palindromes means a string or a number, anything, their values should be same when we iterate from left to right and from right to left. You can see there are 3 log statements, so they are the best example. You can see 1 2 3 2 1. So is this a palindrome or not? Yes, it is a palindrome, because you can see when I read the uh, value from the left side, so you can see 1 2 3 2 1, and also from the right hand side it is same. So it is a palindrome. And for the line number 21 is not palindrome condition, you can see, and 22 is also a palindrome condition because the number is same from left and right. So in this code, the code defines a function is palindrome. To check if the number is palindrome, it converts the number to string uh, and initialize 2 pointers left and right at the beginning and end of the string respectively. It then iterates through the string, compares characters at the left and right. If any pair of characters don't match, it returns false, indicating the number is not palindrome. If the loop completes without finding any mistake, it returns true, confirming the number is palindrome. Otherwise, in the another condition, if it reads uh, different from both the sides, then it will return false. So that's all. Now question number 11. So here you can see that this code uh, defines a function. You can see there are 2 initialization, left and right. This code taking variables left and right to identify a peak element in a given array using binary search. It initializes left and right pointers to the start and end of the array. It iterates, narrows down the slowly uh, uh, by calculating the midpoints and comparing adjacent elements. If the element at the midpoint is greater than or equal to, you can see in the condition greater than or equal to its neighbor, it is peak, returning their its index. Otherwise, it adjusts the search space between on whether the midpoint neighboring elements are increasing or decreasing. This process continues until a peak is found or the search space is exhausted, resulting in a time complexity of O logs to the power n. So that's it. Now question number 16. This code aims to find the missing integer in an array of consecutive numbers from 1 to n. The traditional approach, uh, you can see here, uses a hash set to store array element, then iterates through integers from 1, you can see, to the n, checking for presence if they are present in the set or not. If any integer, you can see, if absent, it returned as a missing number, it will return the missing number. The optimized approach applies cyclic sort by swapping the elements to their current position, then traverse the sorted array to find, you can see here, to find the first mismatch between an element and its index plus 1. This here in this condition, this efficiently identifies the missing number. Both approaches have O's to the n time complexity. So that's it. Now the last question is 21. So this question, so you can see this code, uh, you can see this function, this code aims to find the maximum bitwise and of the two numbers in an array. The worst max bitwise function employs nested loops to generate all possible pairs of numbers and computes their base bitwise, and it updates the maximized bitwise and found so for while ensuring it's not equal to maximum integer value. This approach has a time complexity of O n to the square due to nested loops. Conversely, the best max bitwise function optimizes this process by still iterating over pairs but only updating the maximum uh, if the number, yes, see, pair, you can see if the number in the pair share a leading one at the same position. This reduces uh, the number of comparisons significantly, resulting in a time complexity of O n to the power square in the worst case, but typically faster in the practice. This code then implies these functions to example array and print the output. So guys, that's all for this video. I hope you like this video. Thank you.